I'm Ashley Leo, and this is my EM2 statistics presentation. I chose this topic because of my own daily caffeine intake as a teenager. I wanted to find out if others might also be consuming too much. According to the China's News Asia's article, Are Children and Teenagers Taking Too Much Caffeine? Many teenagers in Singapore frequently consume caffeinated beverages like bubble tea and coffee. This supports my hypothesis that the average caffeine intake among teenagers may be higher than the recommended limit amount of 100 mg per day. My test will determine whether Singaporean teenagers' actual average caffeine intake differs from this guideline. So, my hypothesis. My null hypothesis is that the caffeine intake is equals to 100 milligrams. The population mean daily caffeine intake among Singaporean teenagers is 100 milligrams. But my alternative hypothesis is that it does not equals to 100 milligrams. The population mean daily caffeine intake among Singaporean teenagers is different from 100 milligrams, meaning it could be less or more than the null hypothesis. Reasoning. Even though some teenagers may consume more caffeine through coffee, bubble tea, or energy drinks, others may drink less or none at all. Because the difference could go in either direction, a two-tailed test is appropriate. Part 3. Collecting my data. The population I collected from was teenagers aged 12 to 18 in Singapore. The sampling method I got was convenient and simple random sampling via a Google form survey. The sample size is 35 responses. The survey questions included age range, type of caffeinated drinks consumed, coffee, tea, soft drinks, energy drinks, or none at all, and the number of servings per day. Participants were asked to specify the type and quantity of beverages they consume daily. Why is this sample suitable? The participants are teenagers living in Singapore, which matches my target population according to the article. A sample size of 30 or more allows the central limit theorem to apply. The data is first-hand, relevant, and collected ethically. Experts warn that teens should limit their intake to 100 milligrams per day, but many may exceed this without realizing it. My survey aims to explore whether this is the case. First, I calculated the mean caffeine intake using the formula average AA2 to AA36. This gives the average amount of caffeine consumed by all my respondents. Next, I calculated the standard deviation using equals STDEV dot S bracket AA2 to AA36. The S means it is for sample data. Standard deviation shows how much caffeine intake varies among people in my sample. It helps me see whether most people consume similar amounts or if there is a big difference. It also matters for my hypothesis test because it affects the t-value, p-value, and how reliable the mean is. I used columns AA2 to AA36 because that's where all my respondents' caffeine intake is. After that, I found the sample size using equals count bracket V2 to V36 because respondents 1 to 35 are in that range. Then I calculated the test statistics bracket T value using the formula equals bracket AH1 minus 100 divided by bracket AH2 slash square root AH3. AH1 is sample mean, 100 is my claimed population mean, AH2 is the standard deviation, and AH3 is the sample size. Next, I calculated the p-value two-tailed using equals t.dist.2t bracket abs bracket AH4, comma, AH3 minus 1 bracket. AH4 is my test statistic, and AH3 minus 1 gives the degrees of freedom. Then, I calculated the margin of error with the formula equal confidence.t bracket 0.05, comma, AH2, comma, AH3. AH2 represents my standard deviation and AH3 represents my sample size. This gives the amount of estimate could differ from the true population mean. Lastly, I calculated the confidence interval lower bound using equals AH1 minus AH6, where AH1 is the sample mean and AH6 is the margin of error. This shows the lower end of the range in which the true mean is likely to fall. Thank you.